Hi, I'm going to just sit here on the screen and do a little quick practice on electron configurations, how you do them. A reminder that the periodic table is actually a map to electron configurations. See the first row, 1s1 and 1s2. The second row, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. They're like addresses. They're like electron addresses. But what they really are, as you know, is they're the shapes in which the electrons are being held in these orbitals or these shells. They're the particular kinds of energy level orbitals that electrons are being parked in, or how they're being held around the nucleus. And they have specific energy levels, 1, 2, 3, 4, 5, 6, 7, and they have specific geometric shapes like S, P, and D. So that's the thinking behind it, but the skill set is just this. We're going to read the electron configuration off the periodic table by starting at the lowest level and going as high up as we need to park all the electrons that that particular element has to park. So we'll do it with bromine, and then I'll show you another place to find this. In this box right here, this is actually showing the largest electron configuration that you could have for the largest element. Something would be all the way out here in the position of 7p6. There's no element out there using that, but this is as big an electron configuration as you could possibly have. So our question is, how far up do we go in that electron configuration to think about the arrangement of the electrons for something like bromine? And bromine is small, 35. It's right here, Br, 35. So you can see bromine. And so my question is, what's the complete correct electron configuration for bromine? Well, we got to figure out how far up this configuration do we have to go till we get to 35. But the way to do that is just walk up the periodic table. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So notice that it's stopped, not at 4p6, but because of bromine's position, it stopped 4p5. So let's just write that out so that we have that example. It's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. So that's the complete correct electron configuration for bromine. And notice also that we said, hey, guess what? The 3 Ds actually fill up before the 4 Ps, but after the 4 S's. So it's weird because it doesn't say 3S, 3P, 3D. It goes 3S, 3P, 4S, 3D, 4P. That's also what you're seeing in this diagonal diagram here. But the bottom line is the 3Ds don't open up until after the 4 S's. Even though they're on the 4th row, they belong to the 3rd energy level. Now let me just show you one more thing, and then you can practice some of these for some other elements. ptable.com has properties, electrons, isotopes. So go to ptable.com and click on electrons, and notice this. If I go to bromine and I click on bromine, first of all, right here, it gives that expanded electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. That's what we just said. So it's actually telling me that electron configuration right here on p-table. It's also showing me that in what's called an energy diagram. So we're going to learn to diagram things this way. Here's the 1s down here, the 1s with 2 electrons in it. That's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p, 1, 2, 3, 4, 5, 4p5. So there it is again. So there's a lot of ways that we're actually seeing this electron configuration, how it's reflected by the periodic table, how we can actually walk up the periodic table to determine it, how far we go to park 35 electrons around neutral bromine. But also I can see that the periodic table ptable.com site tells me that expand electron configuration. So really quickly, let me look it up for magnesium. Oh, magnesium, 1s2, 2s2, oops, went to potassium. 1s2, 2s2, 2p6, 3s2. So that's a quick review, really short practice on how you can do electron configurations. Why don't you try practicing one right now for, oh, let's say you could do one right now for a different substance, like why don't you practice aluminum, aluminium, see if you can get aluminum electron configuration correct. That's Z equals 13. And then let's give you a harder one. Why don't you try it for strontium, which is a bigger element. And for strontium, the atomic number is Z equals 38. And see if you can get the complete correct electron configurations for those two for yourself. Just say it the same way we did, okay? That's all. We're gonna stop.